Hey guys, welcome back. Did you guys get amused after hearing the shocking news that the James Webb Space Telescope that just provided the world with the deepest ever view of the universe has been permanently damaged by asteroid attacks? According to Live Science, NASA's James Webb Space Telescope has been crushed by at least 19 small space rocks since it began its journey in December. It's like one larger rock has taken off irreversible damage on one of the telescope's 18 gold-plated mirrors. Hey. Okay, so how is NASA responding to the news? NASA broadcasted the news about the meteoroid strike, telling it had built the telescope to overcome the exertions of space and knew there would be rare micrometeoroid strikes. Lee Feinberg, who is the Webb Optical Telescope Element Manager at NASA's Goddard, clarified the team knew a strike was bound to happen at some point, explaining, "With Webb's mirrors exposed to space, we expected that occasional micrometeoroid impacts would gracefully degrade telescope performance over time. Still, the debris was more sizable than pre-launch modeling had accounted for, and for a cause the scientists are unsure what long-term effects will come from the damage as reported by space. Each micrometeoroid caused degradation in the wavefront of the impacted mirror segment as measured during regular wavefront sensing," told NASA, as per the report of Sky News. NASA has called the occurrence an unavoidable chance event and says they will use it as a chance to improve their knowledge of the solar system dust particle environment. You guys are excited about the cause of this incident, right? According to Live Science, the US Space Surveillance Network keeps track of more than 23,000 pieces of orbital debris, measuring larger than the size of a softball, but millions of smaller pieces go through space undetected. The Desert News reported that the first image was captured by JWST and was discovered last week at a White House incident with President Joe Biden and NASA officials submitting never-before-seen views of the galaxy. According to the Associated Press, the first image was published from NASA's $10 billion James Webb Space Telescope. It offers the widest look of the cosmos that has ever been captured. The image was discovered at the White House on Monday by President Joe Biden and NASA officials. 4 more images were also released. According to NASA, a full series of Webb first color images and data, known as spectra, are expected to be released soon. Recently, NASA reported that NASA's James Webb Space Telescope has produced the deepest and sharpest infrared image of the distant universe to date. What does the James Webb Space Telescope images for, or what would they show? The picture called Deep Field SMACS 0723 shows thousands of galaxies, including the dullest objects ever observed in the infrared, according to NASA. Where DPD says that what appears to be tiny specks in space are actually galaxies that are billions of years old. That's spectacular. To date, we are conquering the secrets of the universe. NASA Administrator Bill Nelson explained during the event at the White House, "We're looking back more than 13 billion years. As reported to the Washington Post, light travels at 186,000 miles per second, and that light that you're seeing is from one of those little specks has been traveling for over 13 billion years. The image catches just a tiny portion of the universe. If you held a grain of sand on the angle of your finger at arm's length, that is the fraction of the universe you are seeing. Just one little speck of the universe," as said by Nelson, said, according to NPR. Washington Post's science reporter Joel Ochenbach interpreted it as a hornet's nest of brilliant but enigmatic objects in many colors. A smattering of stars have parked themselves in the foreground, but everything else is a galaxy, a vast accumulation of stars represented into a small splash of light by the immense distances involved. Have you guys thought about what is the James Webb Space Telescope? This $10 billion telescope was dispatched in December. It is a more advanced type and is a capable inheritor of the Hubble telescope. The James Webb Space Telescope, JWST, is no longer bound to Earth. In a globally followed event that was honored by scientists, engineers and viewers alike, JWST is on its way to an eventual sitting point, from where it will peer out into the ancient space. JWST is the most powerful space telescope ever made. JWST is expected to give humans a look into the universe's earliest luminaries, which were formed soon after the Big Bang. In significance, it is organized to provide one of the biggest questions that science has asked. That is, how did the universe evolve and how did we get there? What are the reasons for our existence on this planet? On this note, here is looking at how the James Webb Space Telescope differs from Hubble Space Telescope, HST, the fundamental technology that powers it, and why it is becoming such a big deal. It is the piece de resistance of the James Webb Space Telescope, JWST, is its primary mirror, the largest one ever built for a telescope. The main visual element combines 18 gold-plated beryllium hexagonal mirror segments to create a 6.5 meters wide primary mirror. This will work at a super frigid temperature of -223 degrees Celsius, 50 Kelvin, to capture red-shifted infrared ranges coming in from the distant corners of the universe. JWST has been designed to focus on the infrared part of the spectrum from 0.6 red light to 28 microns infrared. That means it won't be able to see in UV light like that of the Hubble telescope, but but we'll be able to focus on infrared bright objects like awfully distant galaxies. Light travels in a range of frequencies along the electromagnetic spectrum. Our eyes have developed to detect the band of the spectrum which is known as visible light, which is unsurprisingly given that our atmosphere blocks out several of the other wavelengths. Still, there are many other forms of light we cannot see, both inside and outside our atmosphere. Because JWST is not able to cover the same types of light that Hubble telescope is capable of, it isn't completely replacing the same abilities that Hubble has. However, while we will lose out on the ability to see ultraviolet light in the same way that Hubble accomplished by broadening the range of wavelengths out to infrared light, JWST will provide access to a part of the spectrum that the Hubble telescope never had. Hubble is 13.2 meters, 43.5 feet long, and its maximum diameter is 4.2 meters, 14 feet. It is about the size of a large truck. Hubble's aperture is the part capable of collecting light and in 2.4 meters across. The JWST sunshield is about 22 meters by 12 meters and 69.5 feet by 46.5 feet. It's about half as big as a 737 aircraft. You know the sunshield is about the size of a tennis court. JWST's aperture is around 6.5 meters. JWST will have a huge sunshield used to help keep the telescope cool when needed. This is important for all space telescopes, but is particularly true for infrared telescopes like JWST, as warm objects emit lots of infrared light. If the telescope itself is not kept cool enough, then the telescope risks blinding itself to the light of any object it is trying to observe. The main improvement here, though, is the telescope's aperture. This is effectively the size of the void at the end of the telescope, or in the case of the telescopes like these, the size of the mirror that is used to receive the light. It's the equal of the pupil at the center of our eye, the dark hole that lets in light. The larger the slot, the more light in the telescope can gather in one go, and so the fainter an object it can see. However, Hubble, with its 2.4 meter aperture, can see objects at least 60,000 times fainter than the human eye, which is largely expanded by using cameras to take long exposure photographs. With a mirror almost 3 times wider, JWST will be able to see objects almost 9 times fainter than the Hubble telescope, allowing us to gaze even further into space. It's like with JWST we had so many missions and hopes. JWST will not orbit the Earth, rather it will sit at the Earth-Sun L2 Lagrange point. This point is around 1.5 million kilometers farther away from the Sun than the Earth. Space-based telescopes have a larger purpose than ground-based ones. By being above the atmosphere, they don't have to stare through the changing positions of air to see deep into space, granting them a clearer picture than most ground-based telescopes can achieve. The biggest advantage is that they are also unaffected by the weather, which can be a big problem for astronomers. However, being in space gives rise to fixing things that go wrong much more difficult. The Hubble telescope famously had a small disadvantage in its mirror upon launch that required a mission in space to fix. Okay, so what do you think of the asteroid attacks on such telescopes? Do let us know your points in the comment section below. Hope you guys liked the video. Make sure you subscribe to our channel to stay updated on such amazing content. Please do check out our other videos on this channel. See you in the next video. Until then, bye!